Okay, so we're going to look at our practice problems in Module 1. Module 1, you're going to notice here is an introduction to statics/math review, and really predominantly math review. I want to make sure that you all feel confident with the math that we're going to be using. So for some of you, you may be actively in math or be like on top of it, but some it might not have been for a while that you've looked at these concepts. And some might be wondering, well, what is the math that we're going to be using? So this gives us a pretty good overview of the math that we're going to be using so that if you feel comfortable with this, you can be sure that you're ready for statics and you're kind of ready to go. So what we're going to do is we're going to skip down to the practice problems. Okay, so I'm going to go down to the practice problems. For those in the room, I did hand out the hard copy of this, but the practice problems are going to be found here in PDF format. So you can simply click on that or download it, and you're going to find all of the questions. Now I'm going to go underneath my camera. We'll find this very same thing, but in hard copy form. Okay, now I'm going to just kind of check here. For those in the room, see how my lights work here. Let's see. Again, this isn't a room that I use very often. If I dim the lights a little bit, is that a little better for you guys?
Yes. Yeah.
Oh, maybe not that one. Let's try this one. I'm trying to get this one. It's just this bank off and oh, there we go. Is that okay for everybody? It's not too dim if you're working. Okay. All right. So then I should be, there we go. Okay, so as we look at the practice problems here, and because this is our first practice problems, I kind of have this kind of written out with all the, if you would, rules. So remember, practice problems are basically you're showing me the notes that you took in class, and I'm kind of telling you the things that I want to make sure that you have, because again, it's going to lead to our application problems. So you either get 10 points or you get 0 points with a consideration of 1, 2 mistakes, that are there. But for the most part, I'm looking for formatting and I'm looking that you completed everything that we did in class. Okay. So I'm really checking for completion. You only get one chance to submit from now through the due date to the end of the 7-day grace period. Okay. So you kind of have, if you would, a whole week to get things in. Follow along with the lecture demos here, work the following practice problems, make sure that you use pencil, okay? Because if you do make a mistake, my expectation is that you're erasing and you're handing in something that's neat and easy for me to follow. If you're using pen and you do make a mistake, you're gonna have to scribble it out, and that just, I don't know, it just doesn't look good. So we're looking at neatness, and we're making sure that it's something that we can follow along with, okay? And I'll be demonstrating what I'm looking for. I also like you to put a box around your final answer. So I want to know that this is where the problem ends, if you would. And if a problem gets, more than a couple steps, successively, then it's always good idea to number your steps as well. Let's see here. Important note, this assignment is graded for completion, as we said, earn all 10 points. I'm not going to read that again. And then here too, we'll be going through, it says, write the original equation. And then if there is any fractions, now because of the nature of how I had to write this out using Microsoft Word, you'll notice that I have fractions with the slash, but I'm going to demonstrate for you. I always want you to write those in an up-down format, meaning numerator on top, denominator on the bottom, so that as we work through, especially when we get into things like unit conversions, we can see those things cancel top bottom and we can see what's left over. So when you're writing out your work, we don't want to use slashes, if you would, for that fractional form. So let's get started. What I'm going to do is on a separate piece of paper, I'm going to write out each one of our problems, and we're going to start with set 1. We're going to go down to set 2, set 3, and set 4. Okay. And again, these are to, give you a good understanding of what you're going to be doing for your application problems, which are going to be similar, but different numbers and such. So I'm going to go underneath here. And you don't need to tell me it's practice problems. You don't even need to tell me your name, because when you submit, I'm going to know that you handed it in underneath the practice problems for module 1. And I'm also going to know it was you that handed it in because it's, it's submitted by you. So, so you can kind of jump in here. And as you'll notice that we do have, this called set number 1. So you can just, start with set number 1. Okay, and then this first one is going to be problem number 1. My expectation is that you are doing these in order. Please don't skip around, throughout. I know maybe you might skip one because you might not understand it, need to come back to it, but please keep it in order. It's just easier for me to do the correcting. So we always want to start out by writing the problem itself out. So for this one, let me zoom in here. It says solve for V in this, statement here. So D is equal to V times T2 minus 1. So what we're going to do is we're going to always write out the statement first. So D is equal to V times T2 minus T1. Okay, so write it out first, just the way that you see it. And then it's asking us to solve for V. Okay, so I'm just circling it just for our purposes right now, but I want to get V by itself. So as we can see here, it's multiplied by T2 minus T1. So because it's a multiplication on the right-hand side, to get it over to the left-hand side, I like to say we're going to do the opposite. So if it's multiplied, to me, the opposite is dividing, right? So I'm going to divide both sides. You don't necessarily have to show divide by T2 minus T1. All you got to do is, for my purposes, I just want to see D divided by T2 minus T1 is equal to V, and that would be it, okay? If you did want to do that intermittent step and kind of show how you divide both sides and then rewrite it, but then this would be my final answer, solving for V in that sense. So you want to say V is equal to, so don't, even if it says solve for V, don't stop at D divided by T2 minus T1, actually have V is equal to, and whether that V is on the left-hand side or the right-hand side, do what you prefer. If you want to, some people kind of like, I always like my unknown variable on the left-hand side and then it's equal to whatever on the right. I'll let you decide how you want that to be. But then make sure you put a box around your final answer because that tells me this is the answer to that question that it asked. You don't have to write out solve for V at the top here. Okay. All right. Questions on that? Pretty basic. All right. Let's do another one. Go to number 2. Number 2 says, we're going to solve for R. Now it has these two little stars by it. Notice that up here, this is where it says, make sure to write out the original equation in up, down, not the slash format. This has a fraction in it. So it's going to be I is equal to capital E plus lowercase e divided by R. So we want to write that out as I is equal to capital E plus lowercase e divided by R. So that's what I mean by up-down format, not the slash. So now we want to solve for R, okay? So in this format, because it's divided on the right-hand side, we're going to do, again, I consider the opposite, multiplying both sides. So all I would do is I would say, okay, R times I is equal to E minus or plus E in parentheses. And then to get R by itself, I'm going to divide both sides by I. Again, if you wanted to do the divide by I on both sides, you're welcome to do that. I'm not going to require it, but I'm going to do R is equal to E plus E divided by I. And then this is solving for R. Does that make sense? So you kind of get the level of how I want to see it written out, if you would. Also making sure that it's easy to read and understand, okay? Things that sometimes come up with students are, for instance, S's and 5s. Remember, 5 is an actual, if you would, constant or a number. S would be a variable. Make sure that S's don't look like 5s, okay? I mean, that's just one I can think of that comes up every so often. Okay, let's do number 3. Okay, so number 3 says solve for H. We have those 2 stars again. So you're going to notice that there is a division symbol. So we want to write this out. So we have the division up, down, and we're going to solve for H, which is right there. So I'm going to write it out in its original form here first. P is equal to BH times 1 minus A, parentheses, divided by 2D. So I want to solve for H. So the first thing I got to do is kind of get H by itself. So I want to get rid of what's around it. So I'm going to start by getting rid of my 2D and multiplying it up. So that means it's going to be 2DP. It's going to be equal to And then this can be BH times 1 minus A. I'm gonna kind of get rid of that extra set of parentheses. And then now I want to get rid of the things around H. Since B is multiplied by H, I'm going to divide by B on the left-hand side. So I'm going to kind of cancel that out there. And then I'm going to also divide by 1 minus A. So this is why I have a pencil. I'm going to take B, I'm going to scooch it over a little bit, and this is going to be 1 minus A. Okay. Don't leave it in this form. You know, I kind of do this as my intermittent step. So then I'm going to have 2dp divided by B times 1 minus A is equal to H. And that should be your answer. So I'm going to check in virtually. Let me see. How can I see you guys? There we go. Does anybody have any questions virtually? Is everything going okay? I'll just watch the chat box here for a little bit. All good here. Okay, thank you. All right, I've got a thumbs up. Awesome. No questions. Okay. All right, cool. And then don't hesitate. I'll keep an eye on the chat box here. So you definitely can let me know. So I'm going to go back underneath. Okay. All right. So then we're going to go to number 4. Now I'm writing kind of big just by the nature of I'm trying to make sure it's large enough so that everybody can see. So I only got 3 problems down my page here. You know, if you want to do it in a smaller format, you certainly may. Okay. So we're going to do number 4. Okay. So we're going to go to number 4. Number 4 says solve for L. This is another one that has a division slash. So make sure you do it up, down, and we want to solve for L in this case. So I am going to write it out first. So it's going to be AL divided by H is equal to K times B1 plus B2. Okay. So I want to solve for L. So again, I'm going to be multiplying up my H. So this is going to be, if you would, times H. I'm going to add it at the end here. And then I'm going to divide by my A. So you can do something as simple as that. And then you can write out L as the final answer. I'm going to bring the H to the front here, just like because it looks better. So HK times B1 plus B2 divided by A is what L is equal to. Okay. So now in this section, there are 2 more. Okay. So there is 5 and 6. I'm going to let you guys do those on your own. I'm going to do it in the background here, and then we can compare and you can make sure you're on the right track. Okay. So I'll kind of zoom in here a little bit. So 5 is solving for R2. Keep in mind that these are slashes. You want to do them in up, down, and then solving for W for number 6. So if you get done with those two and you want to compare, I do have those up here. And again, as I'm demonstrating here, this is the formatting that I'm looking for. So to kind of show your work as you go along so that in the event we get to the final answer, let's say you're off a little bit, if I can backtrack and find where the issue was, if it's something little that happened, maybe, forgetting a minus sign or multiplying instead of dividing right at the beginning, then I can see that, oh, you kind of followed through okay. You just missed that one little thing in that spot, but everything else looked good. It's not a big concern of mine. But if I see kind of, a bigger issue, then we know, what to address. So that's why I want to see your work. And also I can give you more points. When we get into the application problems, there are going to be more points assigned to the individual problems. And I want to try to give you as many points as possible. So that means I got to see your thought pattern. And I got to see the work that you do. Okay. All right. Any questions on set number 1? Easy peasy? Yeah. All right. That's where I want you to be. So algebra, that's going to be a subject that we're going to be actively using, all the time, not only in this class, but going forward as well. So being really good on that. Our second set is down here in that first column. Our second set is 2 equations, 2 unknowns. So very often we end up with problems where we find that we have 2 unknown values and we can use what we call 2 equations to solve for it. So it's 2 linear problems, if you would. So we're going to use the substitution method to solve for each of the variables in these 2 problems. So this is a little bit of a process, okay? So we're gonna do number 7 first. It's giving us our 2 unknown, or giving us the 2 equations, but they each have 2 unknowns in them. So what we're gonna do is we're gonna first start by writing the 2 equations out in the form that we see here. And again, making sure that we use the up-down fraction format, not the slash format. Okay. So. This is set 2. And this is number 7. So b divided by 2 plus d divided by 3 is equal to 4. And then we've got 3b divided by 4 plus d divided by 6 is equal to 4. So as you can see here in each one of these equations, we've got 2 unknowns and they're the same 2 unknowns. So we can use the substitution method to solve for b and d. Now, when we look here, what we want to do, the first step that we want to do for these problems, and you don't necessarily have to write this out, but I'm gonna let you in. We want to solve one equation in terms of the other. Meaning, I want to pick one of my variables in one of the equations, so either b or d, and I'm going to solve that equation so that I solve for b, and then the other side of the equation has d on it, okay? And I'm gonna pick one of those to do that. So that means that I'm going to identify this top equation as number 1, and the bottom equation is number 2. And again, 2 equations with the same 2 unknowns. So b and d are our unknowns here. So sometimes there's one equation that makes sense to solve for one variable in terms of the other, but in this case, it really doesn't matter. So what I'm going to do is I'm going to use equation number 1. And because b is the first variable on the left-hand side there, I'm going to say that I'm going to solve for b in terms of d. So that means I want to get b by itself on the left-hand side of the equation and everything else equal to on the other side. So I'm just going to simply rewrite this right now. So this is equation number 1. So I've got b over 2 plus d over 3 is equal to 4. So I want to isolate and get d by itself, or b by itself. So first I'm going to take my d over 3, I'm going to put it to the other side. So because it's added over here, I'm going to subtract it on the other side. So I'm going to have b divided by 2 is going to be equal to 4 minus. Now, here's where, depending on your level of comfort with fractions and problems like this, I like to convert them to decimals. So inside, what I'm going to do is, since this is d over 3, this would be 1/3 or 0.333 d. I'm going to put it in decimal form. If you wanted to keep it in fraction form, go ahead. All right. So I'm going to say minus 0.333. Now inside the problem, you always want to hold at least 3 decimal places and then do a rounding at the end. So I'm going to say 1/3 D or 0.333 D. Okay. And then I need to get B by itself yet. So this is a divide by 2. So that means it's going to be multiplied by 2 on top here. So B is going to be equal to 2 times everything here. So it's going to be 2 times 4 minus 0.333D, right? So I'm going to distribute the 2. So it's going to be B is equal to 8 minus, and it's going to be 2/3, right? So if I take 1/3 times 2, it's going to be 2/3. So it's going to be 0.6667 D. Okay. Oopsie, I don't need a parentheses there. So now what we have here is we have B isolated on the left-hand side, and it's equal to the stuff over there that has D in it. So we're just going to kind of keep this on the side right here because we can't solve for this right now because we've got 2 unknown variables. So what we're going to do is, since we used equation number 1 to get this far, we're going to leave it there. We're now going to take wherever we see B in the second equation, we're going to substitute the right-hand side over here. So we're going to go back up here, okay, and we're going to write now equation number 2. So this is going to be 3B divided by 4 plus D divided by 6 is equal to 4. Okay. What I'm going to do is I'm going to change these to decimals so that they're, in my mind, easier to work with. But again, holding enough decimals that it's not going to affect, or at least adversely affect, my final answer. So I'm going to switch this to 0.75B plus, now the decimal equivalent of 1/6 is 0.1667D is equal to 4. Okay. So now I have my 2 unknowns, but I know that B is equal to this. I'm going to take this part, 8 minus 2/3 D, and I'm going to substitute that in wherever I see B. Okay, so that's why it's called the substitution method. So I'm going to take 0.75 times 8 minus 0.6667D plus 0.1667D is equal to 4. Now we're going to distribute, and you're going to notice that what's happened here by that substitution, I've only got 1 unknown left, right? And that's going to allow me to combine those once I distribute. So go ahead and distribute 0.75 times 8. So that's going to be 6 minus, that's going to be 0.5 or 1/2 D plus 0.1667 D is equal to 4. Now I can combine these two because they have the same level of variable. Okay. So we're going to have 0.5, negative 0.5. And then 0.1667. So I'm going to have a negative 1/3. So 6 minus 0.333 D is equal to 4. You guys get the same thing so far? Now I want to isolate D. I'm going to move my 6 to the other side. It's positive on this side. So when I move it over here, it's going to be minus, right? So this is going to be minus 6 over here. So I'm going to have negative 0.333 D is equal to negative 2. Okay. I have 2 negatives, 1 on either side. They both become positive, right? And that's why writing out, each step, as you know, it's so easy sometimes to forget a negative or something like that. So take the time to write it out. And then now I'm going to divide both sides. Oopsie. I'm going to divide both sides by 1/3. So D is going to be equal to 6. Now it's probably going to be a little bit of a decimal. Like I got 6.0001, but if I would have done the fractions and done it that way, I would have come out with an even 6. So because I did the decimals and there's a little bit of rounding there, you just drop that value. So for instance, on my calculator, I have 6.0001. All right, but the answer is 6. Did everybody get that value, a positive 6 for D? Now that's one of our variables here, right? These equations had 2 unknowns. So I've got the first one done, D. Now I'm going to substitute this back into the other equation. Now, since I did equation number 2 here to get down here to get D, I'm going to take D and I'm going to substitute it back up into equation number 1. Now, remember, we already solved the equation. We rearranged it for B is equal to. So because that's the other equation, I can take D now and substitute it back up into that equation. Okay, so my next step then is I'm going to say B is equal to 8 minus 0.6667D. And now I'm going to substitute that value that I just got, which was 6. So it's equal to 8 minus 0.6667 times 6. So B is equal to 4. Is that what you guys got? Oopsie. You guys get 4? Okay. So process here, we identify the 2 equations with the same 2 unknowns. So that was, they were given to us in our problem. Then we solved for one of the variables in terms of the other. So again, I arbitrarily picked the first equation and I picked B just because it was in the upper left-hand side there. So we solved and got B equal to everything else. Then using the other equation, equation number 2, wherever I saw B, I substituted the 8 minus 2/3 times D. And that's where we did it in this step right here. And then again, depending on what you feel comfortable with, if you want to hold the fractions or if you want to do the decimals, just make sure you hold a couple places in the decimals, don't round too much. And then you can solve for the variable and then take that variable and substitute it back up here. Okay. All right. So really using algebra substitution method to then solve for each one. And then just making sure that your box is around your final answer. In this case, they want us to solve for the 2 unknown variables. So your boxes should just be around the D is equal to 6 and around B is equal to 4. And that tells me these are the answers you're looking for. Okay. All right. Any questions on the substitution method? Aren't you looking forward to statics? It's like getting fun now, right? This is like the fun math. All right. Okay, then let's do another one. Okay. So the second one that we have here is number 8, and they're identifying the 2 equations that we see here. Now, you're going to notice that we need to distribute the 4 before we start, all right? Because otherwise we have 2 values of y here. So we have to distribute the 4, combine what we can, and get it in its final form, and then we'll be able to establish the first and second equations. So we'll have to do that first. So I am going to start a new. So this is going to be number 8, and I've got 4 times x plus y is equal to 7. Is equal to 7. So instead of writing the second equation here, I want to get this equation in a combined form. So I'm going to distribute the 4, and then we're going to see that we can then combine the y's, and that'll be our equation number 1, if you would. So this is going to be 4x plus 4y plus y is equal to 7. So then we're going to be able to combine these 2. So it's going to be 4x plus 5y is equal to 7. So that's going to be equation number 1. Okay. And then we can just add the second one. Equation number 2 is going to be 5x minus 2y is equal to 0. So these are going to be our 2 equations with the same 2 unknowns, x and y. So step number 1 is going to be solving one of the variables in terms of the other. Here again, I don't think either one of the equations looks like one is easier than the other. Because x is on the left-hand side and just because it's number 1, I'm going to choose to pick one. I'm not looking for, when you start these problems, if you picked one better than the other. That's not the thing. You just pick one and you solve for one of those variables in terms of the other. That's it. So I'm going to start with equation number 1 and I'm going to solve for x. So I'm going to start with, I'm just going to rewrite it here. 4x plus 5y is equal to 7. Solving for x, I'm going to move my 5y to the other side. So I'm going to have 4x is equal to 7 minus 5y. And then dividing both sides by 4, I'm going to get x is equal to, now again, if you like fractions, you can keep them going, but I am going to do 7 divided by 4, and this is going to be 1.75 minus 5 divided by 4. That's going to be 1.25y. And those aren't awful decimals to work with. They're actually kind of nice. Okay, so I'm going to put my little cloud around this one because we got to leave this here. So we've got equation number 1. So I'll kind of put that back over here. So these are my 2 equations. So starting with equation number 1, I want to solve it for x in terms of y. Now, because I used number 1 for this, I can't reuse that equation. I've got to now take wherever I see x, I'm going to substitute the value, the 1.75 minus 1.25 y for it. So I'm going to go to equation number 2. I'm just going to rewrite it here. 5x minus 2y is equal to 0. So now here, instead of writing 5x on the next line, I'm going to write 5 times 1.75 minus 1.25 y. So 5 times 1.75 minus 1.25 y minus 2y is equal to 0. Now I need to distribute, and then we're going to combine what we can. So if I take 5 times 1.75, I get 8.75 minus 6.25. And check my work as I go along here, because I'm doing this. I don't have an answer key in front of me. All right. So I'm doing them right along with you. Minus 2y. So if you see anything suspect, stop me right away. Okay. So that means I can combine these two at 8.75 minus 8.25y is equal to 0. I'm going to move the 8.75 to the other side. So negative 8.25y is equal to negative 8.75. I've got 2 negatives on either side of the equal sign. They both become positive. And then I'm going to divide both sides by the 8.25. So y going to be, ooh, that's an ugly number. 1.0545. Did you guys get the same thing? No?
I started the other,
Oh, that's okay.
started with X and I got 1.061. Is that what the ballpark?
1.061. Oh, yeah. Yeah. As long as I got that. I just want to double check. If you followed along with me, did you get 1.0545? I don't remember the answer, honestly. So I'm just going to double check my numbers here. 6. Yeah, that looks good. Combine these, it's going to be minus. So then the 8.75, what was that? You got the same thing? Okay, then I'm probably okay. I'm probably okay. Oh, I did get 1.0. Let me try that again. 8.75 divided by 8.25. I do get 1.06. Is that what you guys got? 1.0606. Is that what you got? Okay. Yep. Yep. Virtually, or do you guys got the same thing? Just gonna check in real quick. Oopsie. Yes, I got a thumbs up. Awesome. Thank you. Thank you. Thank you. See. All right. So any questions on 2 equations, 2 unknowns? Kind of understand the process. You guys have done this before? Awesome. Cool. Yeah. All right. We've got good math instructors because sometimes, I mean, my old school was really good too, but there was on occasion more than I would have liked. But there were some students that weren't quite as strong. So I find at WCTC here, you guys are very well prepared. So that's good. All right. So those are examples of two equations, two unknowns. All right. So then we're going to go up to some converting. Okay. We're going to practice some conversions throughout your program here. And I like to say that statics is kind of the start of the design in the program. So as you go through here now, you are going to be responsible for making sure that units cancel out. So, so this is a great place to start getting used to doing conversions and getting used to working with units. So, so what we're going to do here is we're going to use a method that I call, and I believe it's the correct name for it, called the ratio method to solve. So whenever you show unit conversions, I want you to resist the urge of going online and finding those calculators where you just punch in the number and it gives you something else. I want you to have in your back pocket a foolproof way of doing conversions. Okay. So we're gonna practice that here. And this is how I want you to do the conversions when you do your application problems. Okay. So, so the first one we're going to do here, number 9, it's 125 inches, and we want to find out how many miles that is. Okay. So, so I'm going to start with writing out the conversion that I want. So this is set number 3, and this is number 9. So I want to convert 125 inches. Okay, you can put it in if you would, abbreviated form, so you don't have to write out inches like it is here. Now, you'll notice that I made this grid. Okay, so as we know, any whole number is literally a division by, I'm just going to kind of put an imaginary 1 underneath there. So a whole number is in the numerator, if you would, of its number, and then it's over 1. We don't write it. 1 is in the denominator, right? When we write that, we're going to put its units right alongside it, and it's, if you would, the numerator spot. Now, any conversion that I do, I always use this format, and different textbooks use different things. Sometimes you're going to see parentheses around these, but the reason I use kind of the line or the grid format here to do my conversion is because then it separates it out as, this is not an equation. This is a conversion. So I can actually add these inside of my work at times. And you'll see this as we go through and come up with other examples down the line. But then you know that that section that has the grid looking conversion, you know it's a conversion as opposed to being part of the equation. Okay. So that's why I do this. I've been doing this. This is how I was taught years and years and years ago. Okay. So I'm going to put where I'm going from up in that numerator spot. And then I've got to kind of devise a plan. So you're going to notice that I want to know how many miles 125 inches are. So normally we really don't know the number that there's how many inches are in a mile. I don't know. But do you know how many feet are in a mile?
5,280.
Yes, that's the one, right? So we know that there's 5,280 feet in 1 mile. And we know how many inches are in a foot, right? There's 12. So we're going to do this in 2 stages. You don't have to try to do it in 1. So go with the things that you already know. All right. So for instance, I know, as I said earlier, there are 12 inches in 1 foot. Now, how do I decide if I go top or bottom, right? The units cancel, and that's why we do the up down. So as we go across here, this is our numerator, this is our denominator, my inches are going to cancel top to bottom. So by going 125, if you would, times 1 divided by 12, I am now in feet. I haven't canceled that out yet. But again, that's not where I want to be, right? So I'm going to move down the line a little further, and I've got to get to miles. So I want feet to cancel. So since it's in the top right now, I'm going to put feet in the bottom here, and miles are going to go up on the top. And this is where now I'm going to put my conversion. So I'm going to put, I know that there's 5,280 feet in 1 mile. And now my feet are going to cancel top to bottom. And what I'm left over with are the miles. And now I'm going to multiply across the top. So I'm going to take 125 times 1 times 1, divided by 12, divided by 5,280. And then that is going to be however many miles. Does that make sense to everybody? Okay. That way you don't have to, and again, maybe you have more confidence in those calculators than I do, but if you just put in your numbers, you're like, oh, hopefully that's the right answer. this you can see, you know, that it actually worked out. So what do you get for a value? 125 divided by 12 divided by 5280. Do you get 0.002 miles? Yeah, yeah. So that's going to be your answer, 0.002 miles. Okay. Virtually, you guys are doing okay. I can't see my chat. There it is. Okay, awesome. Good, good, good. Hopefully you've seen this method. I'm sure you have. And there's different ways of doing it, but it's a popular one. All right, let's do another one. Our next one is 86 centimeters. We want to know how many feet that's going to be. So number 10, we want to do 86 centimeters, and then you're just going to start that right off. You don't have to do anything equal to. You just start your grid. And again, we're in the numerator here because we have a whole number with its units. So now we want to get 2 feet. Okay. Now, this is another one. It's not common to know how many centimeters are in a foot. But what is a common one when we bridge from English to metric?
Meters, feet.
How many what?
How many meters, or how many feet are in a meter?
You could. Do you know how many feet are in a meter? I don't know that one. How many?
Like 3.28 feet.
Yeah, it is like, but what is the one that you know? Do you guys know the inch? Say it again.
0.54 centimeters in one.
That's the one that most of us know. Now you can always look those up, right? They're usually around. So I'm going to use that one. I like that one. So I know that there are 2.54 centimeters in 1 inch. And again, because centimeters was on the top in the first part, I'm going to put centimeters on the bottom so that it cancels out as I multiply across the top, divide by the bottom. And now we know how many inches are in a foot, right? So again, inches is on the top here. I'm going to put inches on the bottom. There are 12 inches, and then 1 foot is going to go on top so that my inches cancel out. So here again, we're going to multiply across the top, 86 times 1 divided by 2.54 divided by 12. And we are going to get you get 2.822 feet, right? And we know it's feet because those are the one that did not cancel out. So good. All right, let's do another one. Now, if you look up, if you go online and you say, I found the direct conversion between centimeters and feet, that's fine. But then show me the ratio of those. So for instance, if you wanted to go right from centimeters to however many feet, that's okay. You can do it in one step. I'm just showing you that you don't necessarily, like you might know one of them, right? And then that way you can do it in a couple different phases. Okay. All right. Number 11. Number 11 is, it's 100 inches squared. We want to know how many feet squared this one is. Okay. So let's see how we do these. These are a little different because they've got powers. So number 11, I've got 100 square inches. Okay, so I'm going to start that out like that. Okay. Now, I know how many inches are in a foot, right? I know that there's 12. So I can say, okay, there's 12 inches. So I'm going to put that on the bottom because inches are on the top. So to cancel out, I'm going to put inches on the bottom. And I know that there is 12 inches in 1 foot, right? Now, when I do this, notice that there is an inch squared here, okay? That means it's inches times inches, right? So technically this is inches times inches. So that means when I do that, I only get rid of one of these inches with this first conversion. I have to do this twice, okay, to get rid of it. So that means that to get rid of the second one, to clear the square, I say, that means I have to do this very same conversion. 12 inches on the bottom is equal to 1 foot. The second one clears the second one and gets rid of the full square. Does that make sense to everybody? So when you have a power, you need to do it as many times as there is the power. So in this case, it was squared. So you have to do it twice. Okay. So, and if we look on top, there's 2 feet multiplied together. So that's going to be square feet. So we take 100 divided by 12 divided by 12. So you should get 0.6944 feet squared. Okay. So that's how we deal with powers. The next one that we're going to do, number 12, this is 64 cubic meters to how many cubic inches? Okay, so this is cubed this time. So for number 12, 64 meters cubed. Okay. Now, because it's cubed, just like we did for the square, we're gonna have to do it 3 times to clear that cube. Now, do we know how many inches, bless you, are in a meter? Now, I'm thinking ahead. I'm gonna have to do each one of these 3 times. So I do know how many inches are in a centimeter, right? And I could go centimeters to meters. But then that means I have to do one of them 3 times, another one 3 times. And I don't know if I'm gonna have quite enough. Well, will I have enough room? I'll have enough room. I'll have enough room. We'll do it. So I'm gonna write close together. But if you do look up how many inches are in a meter, you can do it in one level. Does that make sense to everybody? So I don't want you to think you can't do that. I just want to think of familiar things so that you're not having to look everything up all the time. So I'm going to do 1 meter on the bottom here. And I know that there are 100 centimeters, right? So I'm going to go to centimeters first. Now, one of these meters takes care of only one of the meters here. So I'm down to meters squared. So I've got to do the same conversion, 1 meter, 100 centimeters, a second time and a third time. Okay, so that means 3 of them I've got to do to clear the cube. I'm in centimeters now, and I want to get to inches. So now, as you can see, I'm going to have to do this 3 more times to get it to cubic inches. So I'm going to extend this out. I know that there's 2.54. I'm going to put centimeters underneath so I can get 3 of them in here. I always end up writing bigger than I should. And then 1 inch, 1 inch, 1 inch on top. So then these centimeters, 1, 2, 3, cancel out the ones on the top. And the ones that I didn't cancel out are inches times inches times inches, or inches cubed. So I'm going to take 64 times 100, 100, 100, and then divide by 2.54 3 times. Okay. And I got 3,000, 3,905,520 inches cubed. I did not double check that, but does that look like a correct number? Did anybody else get the same number or no? Yeah, I've got a confirmation. So 3,905,520. I got 519 point blah, blah, blah. Okay. So foolproof method of doing conversions, and you're going to see me always do them like this, and this is how I want you to do this chapter. Again, I know that there's multiple ways of doing them, but I want you to see how you can write them out and see the cancellations, okay? And then you're never wondering, even if you're doing it in your head, do I divide? Do I multiply? Is it supposed to be bigger or smaller? It's all written out, okay? Easy, easy, easy. So we've got 2 more to do here. The next one that we have is going to be 14 PSI. Okay, 14 PSI to newtons per centimeter squared. This one we might have to look up because I don't even think I know. It's direct. Heck. Okay. So this is number 13. We're going to do 14. Now, be careful when we have these abbreviations like this. This is pounds per square inch, right? PSI is pounds per square inch. So we need to write this in its up-down format. Okay, even the units. So we're going to go our little horizontal line, and this is going to be pounds on top, and inches squared on the bottom because it's pounds per square inch. Don't write it as PSI, okay? Same thing with miles per hour. Don't write, like we're going to be doing one like that, MPH. We're going to do miles on top and then per hour. The slash is going to be the per. So we have to expand it out. And then we want to get this into newtons per centimeter squared, okay? So the first one I'm going to do is my pounds. I might have to have somebody look up how many newtons are in a pound or how many pounds are in a newton. You can get out your phone and look, that's okay. We're all adults here. All right, see if you want to grab your phone out. So I just need to know how many newtons are in a pound. So pounds are going to go on the bottom here. Newtons are going to go on top. And I just need to know what that conversion is between those two.
4.44822.
Newtons.
Yes, in one.
Okay, so 1 pound on the, and just tell me that number again, 4.4822.
44822. You can round however.
Up to 4.448 newtons in 1 pound. Okay. So that takes care of my pounds. I'm in newtons per inch squared right now, and I want to get to centimeters squared. Okay. So on the top, I'm going to put inch at the top. And I know that there's 2.54 centimeters in an inch. That took care of one of the inches, right? There's still another inch down here. So I need to do that twice because it's a square. I've got to clear that power. So 1 inch, 2.54 centimeters. That clears the second one. And now I've got newtons per centimeter squared. Okay. So we'll multiply across the top, divide by the bottom. And in a final answer, I don't mind if you put the slash. So if you wanted to do n/centimeter squared, that's totally fine. But when we're working it inside of a problem with the expectation of cancellations, you want to show it up, down, okay? All right, we have one more conversion to do. So any questions on this one before we go ahead? Make sure. Okay. So then number 14. We've got 55. Now here we have miles per hour. So it's MPH. So we want to expand that out again. So we want to put miles on top and hours on the bottom. Okay, miles per hour, not MPH. And we want to find out how many feet per minute this is going to be. So go ahead. You remember 5280 feet in 1 mile. And then you want to get hours in minutes. How did you guys do on that last one? Any questions at all? So you should have gotten about 4,840 feet per minute. Awesome. Okay. All right. So far, you guys doing okay math wise? You feel like, yeah, doing all right. Bored? Easy? That's where I want you to be. Okay. All right. So we have one more section here. So that was converting units. Our last section here is going to be rectangular components, okay? Many times we're going to be looking at vectors, and those vectors are probably not going to be on the X or Y axis. So to have an easier time handling them and combining them, we reduce them or we put them into their X and Y components. I'm sure along the way in math or in physics class, you've done this before. So this is practice again, and it's going to be using right angle trig. So we want to solve for the X and Y components of each one of our forces here. So the call out that I have for each one of these is standard 0 for the degrees. So meaning it's coming from standard 0. So if we look at, for instance, a Cartesian coordinate system, right? Our standard 0 is always going to be over on the right-hand side here. This is going to be 90 going in a counterclockwise direction. This is going to be 180. 270. So any of the angles that I give here. So for instance, this first one is 56 pounds at 55 degrees. What that means is I am measuring from here and going in a counterclockwise direction, 55 degrees. Does that make sense to everybody? Okay. Now for these rectangular component problems, I want you to draw out the vector, sketch out. I'm going to say sketch out the vector, but reasonably. If you know you don't sketch really good and that you don't make straight lines really well, then grab out a straight edge, okay, or a ruler, okay? So in this case, we're going to be, this is 55 degrees. So this is going to be in the first quadrant, right? So we're going to draw just a really easy, diagram, but big enough. I'm going to show you so that we can add our X and Y components. So I've got about, 2.5 inches, 2.5, 3 inches here. And then this is going to be my Y-axis. This is going to be my X-axis. Okay. And we're going to draw then. And again, you don't have to get a protractor out, but you want to do something. So about the halfway point would be 45 degrees. And we want to show it going a little bit more than halfway, to mimic 55. I'm not going to be measuring these with the protractor again. And then we're going to label 55 degrees right there. And then we're going to draw an arrowhead coming from that origin, going out, and we're going to label this at 56 pounds with units, okay? So that's a representation of number 15, a 56-pound vector at 55 degrees from standard 0, okay? Now, to determine the X and Y components, the X and Y components are going to be the equivalent horizontal and vertical forces that cause the same net effect as the 56 going up at 55 degrees. So what we do is through the endpoint of our 56 pound vector, we're going to draw a vertical line going down and a horizontal line going, oopsie, a little bit low here, and a horizontal line going across, okay? Where those intersect, those lines represent parallel lines to the opposing axis. So for instance, this horizontal line crossing over the Y represents the Y-axis, okay, or the X-axis where it would intersect. So now what we're going to do is we're going to draw on the X-axis and on the Y-axis the vectors that are going to represent the length that's equivalent to how much that would be pulling in the upward or Y direction. Same thing for the X-axis. We're going to start at the origin and we're going to draw our vector so that it is going to intersect with the line that came down across that X-axis. Now, a couple things about this. Number one, every one of these lines has to have an arrowhead on it because it's a vector, okay? Vectors are going to represent both magnitude, 56 pounds, and direction going up and to the right. Do not draw these as lines. If they don't have vectors on them, you don't get credit, okay? These are vector quantities, so they have to have arrowheads on them. The other thing that we're going to do is we're going to start each one of our components with its origin, which is going to be the side where the arrowhead is not, its origin at the origin of the Cartesian coordinate system. And then the tip, or where we have the arrowhead, is going to then go up to the intersection, and it's going to be located on the axis system. Do not float this out over here, okay? Sometimes math teachers will show it like that because this is a parallel, right? And what we're going to find here, here's a right triangle, right? So because of that, this length is equal to this. but the position of it is not out there. It starts at this origin. For it to have the same net effect on the body, it's not going to float out here. Same thing with the x-axis, does not float out, or the x component does not float out here. Does that make sense, everybody? So I am super picky on that. If you label and you show your y component out here, it's wrong, because it is wrong. It has to come from the same application point, the same tail as the original force. That is important. Quantity-wise, you can envision the right triangle and that the component would be equivalent out there, but the component is actually located on the x and the y axis. Okay, seems ticky-tack, but it is important, because when we start looking at forces and how they affect a body, we have to place them in the right place, and they can't be floating, out in space over here. All right. Okay. So now what we want to do is we want to label each one of those components. Now, because we're not given, anything, you can just simply call this Fy and Fx. That's it. But they need a label, because now we're going to calculate each one of these quantities. So as we just kind of pointed out, there is a right triangle developed. Okay. So what that means is we're going to look at where our angle is. We know the hypotenuse of the right triangle. And now, depending on what we want to solve for, we're going to use either sine, cosine, or tangent, right? So in this case, if we know the angle is 55 here, and I'm going to start with the x component. The x component, as we look, this is our right triangle. This is the side adjacent to the angle. And we know a hypotenuse. Sine, cosine, or tangent? It's cosine, right? So cosine is always going to be the side adjacent or closest, that's how I always remembered it, over the hypotenuse, which we are given, and we have the angle. So what we want to do is we want to say, okay, cosine of 55 degrees is going to be equal to the side adjacent, which is Fx, divided by the hypotenuse, 56 pounds. And you can use the symbol for pounds when you show an equation. And this is the work that I want you to write out. You don't have to do cosine is equal to side adjacent divided by the hypotenuse first. Just put your numbers in there, okay? And then now our unknown here is going to be Fx, so we're going to multiply up. So my Fx, I'm going to kind of put on the left-hand side here, is going to be 56 pounds times the decimal equivalent of cosine of 55 degrees, right? So what is our value for Fx? You get 32.12 pounds. Now, because our vector has units, pounds, make sure that when you identify this is Fx is equal to, so you're telling me what this value is, so it's Fx, so it corresponds to one of your unknowns, equal to your magnitude, and you have to have the appropriate units, and it's pounds. If this resultant, or if the overall force is in pounds, whatever those units are, is what your components are going to be in as well. Okay, so make sure that you have its quantity and its units. Okay, let's do Fy. Okay, Fy is here. Now remember, we can imagine, or we can kind of equate it to out here, but remember, it's not placed out there. So we're not drawing it off the axis. We're not drawing it out here. It's drawn here, but it's equivalent here. So if we know that we have 55, and if we look across, that would be the side opposite, right? And we know the hypotenuse. Now, another rule I'm sure that your math teacher fill you in on, you always want to use as much original information as possible, right? Original information here is that hypotenuse. Even though we just calculated the adjacent side, if for some reason you have, a decimal place off or something, you don't want to risk multiplying that error. So we're going to go back to original information. So if I want to find the side opposite, knowing the hypotenuse, sine, cosine, or tangent? Sine, right? I heard sine a couple times. Yep. So we're going to use the sine function. So down here, it's going to be sine of 55. It's going to be equal to the side opposite, which is Fy, divided by our 56 pounds. Multiplying that up, our Fy is going to be equal to 56 pounds times the sine of 55. Our Fy you get 45.87 pounds. Again, make sure that you identify that it's FY is equal to your number and then the units. Oops. Now, what does this tell us? So we broke our 56-pound force that was at 55 degrees into two components. What it says is if I pull on that same point horizontally with 32.12 pounds and I pull vertically on that same point with 45.87 pounds, I will have the same net effect going up and to the right as if I would have just the one force. And again, it might not make sense right now. You kind of feel like, why are you breaking it into two rather than one? It seems like more work, but it allows us to combine things along the y-axis, along the x-axis, and then just by their sign, we can add and subtract more easily. So we're gonna be doing that very soon. All right, components. Any questions? Cool. So then we've got just two more. We'll do two more just like this. Our next one is going to be 10 kips. A kip is 1,000 pounds, probably not something you've ever probably used very often. So it's just a shortened version of 1,000 pounds. So it's technically 10,000 pounds when we say 10 kips at 125 degrees. Now, again, kind of thinking of our Cartesian coordinate system, if we're measuring from standard zero in a counterclockwise direction, we're going to be past the 90, right? And this is actually going to be in our second quadrant going up and to the left. And then there's going to be, how many degrees would that be? From 90, 35 degrees, right? From 90. I do it in my head. Okay, so then we're going to draw that again in the appropriate second quadrant coordinate system. So I'm going to draw a little line here. So this time we're going to be in the second quadrant. Make your diagram nice and big. And we are going to be something like this. Okay. And this is 10 kips. Okay. And now this time, our angle, as we said, is going to be 35 degrees. I did that in my head. I got some nods, so I'm thinking it's good, but you might want to double check. So go ahead and draw your X and Y components on the X and Y axis, okay, and label them. It's like we did above. Hopefully you're showing them on the X and Y axis as we see here. The Y should go up and intersect with the line going horizontally over, and the X is going to go to the left. Okay. Now we want to solve for each one of those values of X and Y. So we know the hypotenuse and we know the 35 degrees. Okay. So now as we look here, if we want to solve for the X component, the position of the 35 degrees is here this time. It's a little bit different. So if we look across up here is where we have our equivalent length to the FX. But remember, we're not going to float our FX up top over there. We're just going to imagine it's the same length. So if we look at where 35 is, it would be the side opposite that we're looking for, right? And then we have the hypotenuse. So sine, cosine, or tangent for this one. It's sine again. Yeah. So this one's going to be sine. So we're going to have sine of 35 this time is equal to side opposite, which is going to be our FX, divided by 10 kips. Okay, so remember, kips is 1,000 pounds. So now solving for FX, we're going to get FX is equal to 10 kips times the sine of 35. It'll be neater here, Kelly. Trying to write in a hurry, that's the problem. So our FX is going to be equal to 35 sine times 10. Should be 5.736 kips. Now, you might say, do we put a negative on that? Because it's pointing to the left, right? It's kind of going in a negative direction. The answer is no. Why not? I have a drawing and I have an arrowhead. If I don't have a drawing, if I don't have an arrowhead, yes, then I would have to put the negative on there. But I have a clearly labeled variable that I solved for. So all I need is the magnitude because I've got my arrowhead identified here. And that's always what we want to do. The picture tells us more. Okay. So good. Let's do FY. I'm going to let you do FY. So go ahead and solve for FY. And I'll do it on the side here and we can compare when you get done. Oops. All right, so you should get for FY 8.192 kips. Make sure that you have FY identified equal to the number and then the units in here as well. And then also that FY is labeled on the diagram. It's never a bad idea to make sure that your answers make sense because we've got a right triangle here, either one of these. Notice that our hypotenuse always has to be the largest number. So as we look here, indeed, it's not any larger than either one of the legs. And then also making sure that as we look at the angle, it does make sense that the FX is shorter, considerably shorter than the vertical or the FY. Okay. All right. Any questions on that one? We've got one more, then we'll be done. Okay. So I'm gonna let you loose on the last one and then we'll compare in a little bit. So you're gonna notice for number 17, this is 25 kilonewtons. And this one is at 211 degrees from standard zero. So again, you want to kind of figure out, you should be in the third quadrant, right? This time? Okay. So find the X and Y components. I'll do mine on the side and then we can compare. Okay. Any questions on the last one? You should get Fx is equal to 21.429 kilonewtons. And for Fy, you should get 12.876 kilonewtons. The Fx is going to the left arrowhead on the x-axis. Fy is going down. Make sure you have the arrowhead labeled right now. Okay. Now that is the last of the practice problems, okay, that we have for module number 1. And it also really kind of gives us, I'm not going to say it's like exhaustive, but for the most part, that's a pretty good overview of the math that we're going to be using in this class. And so it's a nice way for you to know, am I ready or not? There's going to be a little bit of calculus, as we go, but we'll kind of cover that a little bit later on. But for the most part, this is the majority. Statics is the majority of it is going to be this. So any questions on that? If you feel like this was really easy, that's exactly where I want you to be. Exactly where I want you to be. If you're like, oh, that was a good review, that's excellent too. But if you're feeling like, ooh, that's a little bit more than I'm ready for, then come and see me. All right. Because I don't want you to, get knee deep and then be frustrated. Okay. So now practice problem wise, you have everything that you need. So this is like an example of how I would do practice problems. We work them in class. You get all of the answers, if you would, worked out. This is the format that I'm expecting, the things that I was emphasizing. And now you're simply going to scan and or take a picture of each one of the pages that you created, clearly labeled in the order. Try to put them in the same order. I know sometimes pages might get shifted around a little bit, but for me, efficiency wise and getting things corrected, it's just kind of nice if they're all in the same order. So let's take a peek back at the practice problems so I can show you how you're going to be handing in. So if we go back to module 1, here's the practice problems, and that's where we got the PDF. Now, mine is going to look different than yours, but there's going to be an upload section, right? Normally. So what you're going to do is I'm going to say the easiest that I find students say is you can take a picture on your phone of each one of the pages. What you want to make sure is that you're directly above. Don't be like at a skewed angle taking a picture of it, because then it's hard for me, like things further away are like wider and blurrier. So go directly above, kind of like your, I don't know, like a copy machine, if you would. It's directly above. And then take the picture, and then you can crop it. I appreciate if you crop out things that are in the background. And then you can submit the actual JPEG or whatever image, your phone takes your pictures in. And you can upload those right here. And you can upload multiples to do that. Some people like to put it in a PDF format. If you want to do like a scanner app and put it in a PDF format and upload that, that's totally fine too, because then maybe they're, all one document as opposed to separate files. The third way that people do it is they'll open up, for instance, like Microsoft Word, and then just insert each one of those photos as well, and then upload that document. Totally up to you. All three of those ways work for me. All right. Just make sure. Now, something that you just want to be sure of, especially when it's on the, it's a picture, you just want to make sure that the file itself is readable. If it's blurry or if I can't read it, I mean, you submitted it, but if I can't read it, I can't give you points. So double check the images before uploading. Okay. So that's practice problems. Really, if you followed along and you kind of did them all with us tonight, we're done with those. Okay. So the other part of your assignment then is going to be the application problems. And as I told you, practice problems are going to mimic the application problems. So if we look at the application problems, we're going to open up that PDF. And I do have actually, let me get them passed out in the room here. I have those here for you in the room. Now, as you look at this, you're going to notice that as we go down, this is our application problem. Set number 1, this is the algebra. There are more problems than what we did in class. So again, the practice is really just to kind of get your feet wet, understand the formatting and such. But now you're just going to do a new set of problems that in a similar way. Okay, so that's set number one. Then if we look at set number two, this is 2 equations, 2 unknowns. There's 4 problems to do here. Same substitution method. Don't do it in any other way. Number 3 section or set number 3 is going to be unit conversions with the ratio method that we showed tonight. And then lastly, a couple more rectangular components, okay, in that very same format that we looked at this evening. So, so those are the application problems. Now, uploading those again is going to be the very same way that we just talked about for the practice problems. And we're going to now look at the calendar, okay? If we look at our calendar, you're going to notice, and I am a little aggressive with this one, but to me, this math should be reviewed for you, and it should be pretty easy. You're going to sit down, you're going to do it, right? It is due on Friday at midnight. That is set due date for both the application problems and the practice problems, okay? Now, according to what we talked about tonight with our syllabus, remember, for full credit, you have an entire week, 7 days. So by the end of the day on the 31st, 1 week later, you can still get full credit for both the practice problems and the application problems. Now, practice problems, if you don't hand them in by the end of the grace period, by the end of the day on the 31st, they go to a 0. Okay. And remember, only 1 submission on those because we just went over them, right? I mean, you got it. The application problems, though, you hand them in anytime during the grace period. That's your first submission. If there's any corrections to be made, you can make those corrections for full points back. So if you get 10 points off, you can earn all 10 points back by just making those corrections, as long as you get them both in by the end of the day on the 31st. So the sooner you do your first submission, the more time you have to do corrections if you need to. Does that make sense? But if you first submit on the 31st, I'm not guaranteeing you corrections because it just depends on my timing. Okay. All right. So that's the deal. Now let's talk about Friday. I got through for module 1 what I wanted to, okay, in terms of information, practice problems, that kind of thing. I don't have anything new to cover on Friday. So this is the deal. Because of that, on Friday, our virtual session, I'm going to make it optional. You guys are adults. So if I would suggest trying to look at your homework, the application problems before Friday, and just kind of see, do I have any questions? Am I having any problems? I don't have final answers for these. Most often I'll have final answers for you on problems coming up, but these are kind of just the math things. So there's not a whole lot to it. So, so do your best. And then, like I said, I can correct them within the week and then go from there. But if you do have any questions, I'll be on at 5:30 virtually from my home. Remember, we're not meeting here on campus on Fridays. That's a Zoom meeting. And if you have any questions, I'm happy to go over any and all problems that you have questions for. I will record any questions that you have. So for the benefit of the group, I'll post that. And then, and that's how we'll handle this Friday, just by the nature. Like I said, we'll kind of play it by ear. I'm always going to try to make Fridays optional work time, but it might not always work out that way. Questions? Oh my goodness, you guys, I got people packing up already. So it's 8:30. I will never lecture this long again. This was totally 3 hours tonight because we had our course introduction, but we also had one less day this week. So I wanted to get through this stuff tonight. So it'll never be this late ever again. I promise you. Normally about 2 hours at the very most, and then work time. Okay. All right. If you don't have any questions, I'm going to let you go. I'm going to kind of close. And then, virtually, I just want to make sure you guys are all set as well. I'm going to stop sharing for a little bit. Any questions that you guys have virtually? If not, that's okay. No questions. All right. Have a good night. Oh, and I'm going to say too, I guess I want to let you know, you're always welcome to stay. We're technically here till 9:30. So if anyone wanted to stick around and start working on your application problems, I'm here for that as well. And I stay, until the last person is here. Okay. All right. Now you can go. Have a good night.
For one of you.
Oh, that's okay. Yeah, and I've got all my papers all over the place here. Number 7.
Kelly,
Is that it? Was that it? It's here. All right, it's bugging me.
Kelly?
Okay, all right. All right. Sounds good. Yes.
Alright, so did you do talk about when you were going on the syllabus for the prerequisites? It's about 5 there.
I just wanted to make sure you, did you have the question? It's the map.
Yeah, I'm taking that right now.
There's a little
Yeah.
bit of Excel before. Oh,
Yeah,
okay.
that's what works.
It's very basic. Okay, it's not gonna be anything super.
So you probably would have took you 45 minutes to do.
Yeah, because
But it's just.
Yeah, they're usually easy.
Because the advisor was telling me.
No, there's-
Special prerequisites, so I can take it from now, so when I saw it, I'm like, oh, whatever.
Oh, you're fine. If you would say that you didn't have the math before, then that I would be more concerned.
That's
But
what-
did the math go okay? from-
Oh, yeah, yeah.
Okay.
I just
perfect.
took trig.
Oh, good.
So I was like,
Perfect,
oh,
okay.
yeah, this.
Then you're good. You're
Yeah,
good. Yeah.
as soon as we start going to math, I'm like, oh, wait, I think the reason she did the prerequisites is because it's the trig.
Yeah.
that
Yeah,
makes sense.
should be good. Okay, all right, awesome. All right, thank you.
Oh, I hate that.
I don't
Five,
think
eight.
that-
I like it.
Damn.
What, it's good, it's.
You know what's nice? They have
Why?
desks like these down in the automation classes, but the keyboard come up from up here.
Yeah, they
Come
come
up
out.
the desk.
That's better.
Not underneath. I need to have that.
It's annoying.
What's that?
All the keyboards are on.
I like
these
that. I
desks
like
up here.
I like this.
Oh, you.
Oh,
like
they're
this
underneath?
better? Oh, yeah.
The ones in the automation classes come up on a level with the thing,
Oh, and then.
and then you can pull them out onto the desk.
Oh, so it's high, you like the lower.
I don't like the lower, I like it up.
I
Because to me, yeah, this, I don't get what the
Can you,
difference is,
can you
but
pull it? Can you?
these ones, yeah, you can pull out, I always
Okay,
do.
yeah.
In your class, I just yank it out.
That's fine. Yeah.
Language. That's you, I mean.
All 4 of us are in Calc too.
Oh,